All right, welcome to AI612, Machine Learning for Healthcare. This is just, chat. Okay, yeah, 안녕하세요. 네. Yeah, if you have anything to, if you want to interrupt or if you have any question, just type it in the chat box, or you can use your voice as well. Right, so to proceed, so welcome to AI612. This is Machine Learning for Healthcare. This is welcome everybody to the new semester. And unfortunately, COVID hasn't died down yet, so I guess everything will be based on online fashion again for 2 consecutive semesters. Wait, is it for 2 consecutive? Actually, no, for 3 consecutive semesters. So this is the 3rd semester, which is conducted fully online. So, which is a bit unfortunate, or not. Depends on your preference. I myself find it rather not super comfortable, but it's not too bad. I guess, like, lectures can be done fully online, which is just convenient for both parties, the lecturer and the TA, and also the student. All right, okay. Before I proceed, I'm going to mute everybody. All right, this is just the introduction, so nothing too heavy on the first day. So the agenda is today we're just going to talk about what is healthcare and why you should care, and what will you learn. So, because machine learning for healthcare, healthcare is not like a super major domain in machine learning. It's usually either computer vision, or it's NLP, or more theoretical like optimization, or like that kind of stuff. But yeah, as I said, so healthcare is not a super major domain. So, well, I thought it would be best to start with why. What is healthcare actually? Because the term itself is just such a broad, abstract term. So the goal of healthcare and AI is to use AI technology to improve healthcare for all. So this is not a statement made by the government or anything. It's just my personal statement, I guess. But I think it could be applied to a lot of people. I mean, it's just healthcare is actually, it has a weird not a weird, but like a peculiar characteristic where people seem to believe that healthcare should be enjoyed by everybody, which I kind of agree. It's like like human dignity and all. So it should be like the machine learning for healthcare shouldn't be used to help only super rich people, or that would be kind of unethical. So it's basically, we want to use AI technology to improve healthcare for all. But this statement again is a little bit vague. So I would say 3 terms could be vague. So one is AI. So what is, like, when someone says, I'm going to use AI to improve healthcare for all, then you can ask, well, what kind of AI are you talking about? Or what kind of healthcare are you talking about? Or you could ask, how are you going to help everybody? So it's just 3 terms that we want to define or narrow down. This is AI tech. This is grad school of AI, so I'm not going to talk about AI. So everybody knows what AI is. So, but the next word, which is healthcare. So what is healthcare? So again, since this is a college of engineering, grad school of AI. So everybody, when I tell people that we're going to use machine learning for healthcare applications, then immediately they think about this. Well, not immediate, but this is like one of the most popular machine learning applications done for healthcare, which is 2016 JAMA paper on detecting diabetic retinopathy. So diabetic retinopathy, which is a disease that you get, is a comorbidity. So like diabetic people have a lot of side effects, not exactly side effects, but the diseases that come along with diabetes. Like, when people, like, in the extreme cases, people have to cut off their limbs, like hands and feet. That's one extreme. Another is that it's usually you start developing some problem with your eye. So retinopathy is I think in Korean it is 망막증, 망막염증. So it's something going on your retina, obviously, due to diabetes. So that's why it's called diabetic retinopathy. And so you take a eye scan, and then based on that, radiologists or eye doctors, ophthalmologists would usually diagnose whether a person is having diabetic retinopathy or not. But Google actually developed a model like way back. Now it's like 5 years ago. So 5 years ago, they developed a model for detecting it automatically. So it was based on a model called Inception, if I'm correct. I think it was this Inception V2 or V3, I'm not really sure. But that performed so well. Actually, it outperformed human eye doctors. So I think they recruited maybe 10 or 15 eye doctors to compete against this machine. And on the average outcome, the machine actually won, outperformed the human doctors in average. So that's saying something. So that work made it into JAMA, which is a very, very prestigious medical journal. So if something's on JAMA, then you can completely trust it. It's like very high impact work. And when something is on JAMA, then the next day that will be used in practice. So it's like a major achievement. So this is one of the things that machine learning people are super familiar with, and when people think about healthcare for AI for healthcare, they immediately think about medical images like X-rays or MRIs or CT scans or eye scans actually, or smartwatches, because a lot of people are familiar with like Apple Watch or Fitbit or Galaxy Watch, that kind of stuff, and or basically how to diagnose diseases automatically. So that's one of that's the straightforward ideas. But actually, healthcare is such a broad term. It's a broad industry actually. So there are a lot of problems hidden everywhere. So for example, hospital administration, it's how to like maintain your hospital or how to run your hospital as a company. But in order to run a hospital, there are a lot of administrative work that needs to be done, and some of them can be done because some of them can be automated via AI technology. For example, readmission prediction. So that's when a patient comes into a hospital and then stays there for like several days or so, and then you discharge them. So discharge meaning 퇴원. So you discharge them, and if as a hospital you discharge some patient too prematurely, and then they end up coming back to the hospital within within a month or something, then the problem lies that responsibility lies in the hospital. So because hospital usually wants to discharge patients as soon as possible so that they can take in new patients, because there are always new patients. For example, these days, if you think about COVID, then there are a lot of patients pouring into the hospital every single day. So if as a hospital you think that a patient got better sufficiently, then you want to let them go as soon as possible. And of course, patients don't want to go as soon as possible. They want to stay in the hospital for maybe extra couple of days just to make sure that they're really, really okay. So there's like a conflict there. And I'm not sure about the Korean government, but the United States government actually focused on the problem. And then they actually made a law that if a hospital prematurely discharges a patient and the patient comes back to the hospital for some reason, then the hospital is fined like a very, very heavy amount of money. So it's like a punitive law. So that's one. So readmission prediction. So this test would be if, as hospital, you decide to discharge a patient, then what is the probability that this patient will end back up in the hospital within a month? So it's binary classification. That's one of the major applications for machine learning for hospital administration. Then there's like other things like automatic triage. Triage is when you end up in a emergency department in 응급실. Then you first have to quickly classify how severe a patient's state is, and then then do apply a appropriate like treatment. So but there's not a lot of time to actually because people who end up in an emergency department, usually they're in a very severe state, so there's no time to actually go through the lab or do like DNA testing or do biopsy. There's no time for that. So you have to really save time, and that's where machine learning can help. Automatic coding for billing, that's another thing that's not really well known among machine learning researchers or engineers, but This is all like very hospital specific problems. So automatic coding for billing is every country has like a health insurance. So, and the way the health insurance works is that you pay some amount of money as a patient. You pay some like a small amount of money, and then usually in in Korea, we have a centralized insurance system. So like if your total hospital fee is like I don't know 100만 won, then you pay like 만 원, and then the rest of the 99만 won is paid by the government. And so in order for the hospital to request for the remaining 99만 won, they have to actually send some document to the government, which is 심평원 actually. So, and in order to do that, they have to, so the hospital cannot overcharge, like they can't just lie to get more money. So they have to actually use a specific code for getting money from the government, from 심평원. So that's a very, very rigorous practice. It has to be some person using exact code, like, oh, I did this service to the patient, and I gave that treatment to the patient. Like there's like code for everything. So and actually it's people who usually do this, but if you can automate that, then people can then like precious human resources like nurses or doctors, they can spend their time on the patient rather than coming up with the code for reimbursements. Other things like daily monitoring, like I'm pretty sure this will be a big thing within like a few years, because everybody has like wearable devices or home cameras or AI speakers lying in their work environment or living environment. So hopefully one day you can talk to a AI speaker and then make an appointment to the hospital, or maybe you can get a quick diagnosis of your status via like remote medical system, something like that. Drug development, if you think about the money that pharmaceutical companies spend for coming up with a drug, which is usually like 조단위, like that's how much. That's like million, million, 10 million, 100 million, like $100 million or so. Anyway, that's like huge amount of money. So if you think about that like if you think about that, then drug development is a really big piece in the entire healthcare industry. So these days, especially because of the COVID, AI-driven drug discovery or AI-driven drug repurposing, that kind of stuff is a really hot topic these days. Lastly, we can think about disease-specific cares. This requires a bit more domain knowledge. Like usually it's one of the medical professors, like professors in the university medical centers, like 의대. They really focus on their own department problems, like like 정형외과, like in orthopedics, orthopedicians, they usually care about orthopedic problems. It's like internalists, like you usually care about internal problems and that kind of stuff. So if you want to, you can actually specify on one disease and try to, for example, what you can do is you can actually model the progression of diabetes or model the progression of Alzheimer's. I've seen a lot of works do that. Like each disease has like a level, like stage 1, stage 2, stage 3, stage 4, and you can actually like try to model the progression of the stages via using like hidden Markov models or something like that. So anyway, so healthcare itself is a very, very large or very, very broad industry. So there are a lot of problems that we are not familiar with. So I'm just gonna put a pin on that. And so the next one is all. So if you want to improve healthcare for all, then when machine learning engineers or researchers think about helping people with healthcare, it's usually helping the patients, because machine learning researchers, when they go to the hospital, they go to the hospital as a patient, not as a provider, like a doctor or nurses. So it's usually they want to find applications to help patients. But actually, again, this is such a broad industry. So all right, yeah, I just muted everybody. All right, so again, this is such a broad industry. So there's a lot of players. It's not just the users. So users are usually patients, but there's also providers. So doctors, like service providers. So doctors, nurses, like social workers, a lot of people like a lot of people who provide medical services are called providers. So doctors are one of them. So there's like another group of like players, and then the hospitals are a bit different from doctors. So doctors are actually like employees working in a company, and hospital is a company. So you can't run a company without making money. So hospital, if you're operating a hospital, then you need to think about your revenue. So, but doctors usually care about, treating people and then healing people. So there's a bit of a like a conflict of interest there as well. Like if you're like a doctor, then you want to do whatever it takes to save a patient's life. But if you're a hospital run, if you're like a CEO of a hospital, then you cannot let doctors, use tons of money to treat one patient. That won't be efficient. So unfortunately, everything is like tied to money problem. It's always financial problem. There's always a financial problem tied somewhere. So like in healthcare, efficiency is one of the most important things, in my opinion. Like, not just saving lives, but also you need to save lives efficiently without, without spending too much money. Otherwise, it's not gonna be put into practice. So there's hospital, and then there's insurance, and insurance can be like a third party company, or it could be like a government. It depends on which country you're in. So in Korea, everybody has a centralized insurance plan, and that's we do have like additional insurance schemes, but most of the things are covered by central insurance. But in United States, it's not the case. In United States, it's usually the central insurance is for very poor people. That I think that was Obamacare, or very old people, which is Medicare or Medicaid. I'm not really sure which one. And then rest of them, young, healthy people with some money, they need to resort to private insurance companies, which is really, really costly. So I think everybody is familiar with insurance problems in the United States. Like, when you lose a job, you lose your insurance as well. And then when you go to a hospital, you get charged for like, I don't know, like tens of thousands of dollars for just taking an x-ray, or just getting getting your cold or flu treated. Then you need to pay like tens of thousands of dollars, 몇 천만 원. So, and then you go bankrupt. So that's like one of the major problems in the United States. Luckily, in Korea, we don't have a problem like that. Anyway, so insurance is another major role player. And then government, again, because government can also have their own insurance problems, or government usually spends a lot of money on healthcare in general. Like on their yearly budget, I think in the United States, in their yearly budget, more than 10% is spent for healthcare. So that's much more than military spending, actually. So, and there's a lot of inefficiency there. So you want like as a government, or as a person in charge of coming up with a budget in the like yearly budget in the government, you want to really make the whole healthcare really, really efficient, so that you can spend less money on healthcare and more money on, I don't know, education or somewhere else. Pharmaceutical companies that does drug development or drug discovery, so that they're another major role players. So all in all, so because of the healthcare industry itself and the players there are a lot of opportunities, actually. So healthcare is a broad term. It covers many industries. Because of that, there are a lot of countless opportunities. The problem is that as a AI researcher, so which is us, because we're students, grad school of AI students, so we don't know what kind of opportunities there are. So when I say opportunities, it means money opportunities, like financial opportunities, or even research opportunities. Like there's like business opportunities and research opportunities everywhere in healthcare. It's just that we don't know what kind of problems there are. So because the problems, doctors or the providers, like players, like here, like people from here, like doctors, hospitals, insurance companies, governments, pharmaceutical companies, they know what kind of problem needs to be solved. They know what kind of opportunities lie to make money, like make tons of money. But they don't know the AI technology that much, like not as well as we do. So that's where collaboration needs to come together. So it's companies and school needs to come together. Like we need to have like a common platform, or like a place to get together and then talk about what kind of problem there are, and then what kind of technology can be used. So it's the AI side and the healthcare side that needs to come together. And because of that, United States is always moving fast. So there, in the United States, like companies and schools are investing. Like for schools, they like have a dedicated like research center for healthcare AI and that kind of stuff. And companies, well, they are the fastest movers in this domain. So like Amazon, Microsoft, DeepMind, Google, they all come up with their own healthcare, either healthcare teams or healthcare departments or healthcare business sides. They all have their own things going on rapidly. So hopefully, companies and schools in Korea can follow up as soon as possible. Yeah. Anyway, so that's the premise of the things going on these days, and focus of this course is I mean, this is AI, so we need the data set, and things like here, like a lot of things here, we don't have the data set for them. Like we can't have Fitbit data set because that's owned by the company Fitbit. Well, actually, Fitbit was acquired by Google, so Google has all the wearable device data, home camera data, AI speaker data. Those data are all like proprietary data from by the product makers. Like in Korea, it would be Kakao or Naver. So we don't have data. So in order to actually do a research and also do AI research or AI study, we need the data set. So focus of this course would be electronic health records. So what may be in the future, like Kakao or Naver would maybe open source their data set for healthcare, which would be like a really big thing, but maybe someday, but at least not today. So we're going to focus on the EHR. But before we go into EHR, any questions so far on the the background knowledge of healthcare for AI? Any question? No. All right, I'll just move on then. So what is electronic health records? We're going to go into that. So EHR. So EHR is actually everything that happens to a patient in the hospital, which is dumped in the hospital database. So this is just a screenshot that I took from Wikipedia. So when you go to a hospital and meet a doctor, then the doctor usually pulls up your record on their screen, on their monitor, and they see a screen like this. So they put you, of course they know your name. So there's like names, and then there's a birth date, date of birth, what kind of problems you had so far. So there's like a diagnosis, and then there's like prior meetings, and then I mean this is just one specific example, but here it seems that the doctor can actually save a screenshot of your of the body part that you have problem with. So, but this is just one example of EHR. Like this is a UI, user interface, and of course different hospital has their own EHR user interface, but you can just, this is just for like conveying the idea. So EHR is like it contains your information in a structured manner so that the doctor can consult, take a look at it when they are doing something, like when they're treating you. So as I said, this is all dumped in the hospital relational database, so we'll get to that later. So the EHR system, so EHR it's a electronically stored data set. So like a long time ago, like maybe like 30 years ago or 40 years ago, everything that happened in the hospital, like when doctors treat you, then they write that in the paper, and then they put it in a folder, and then they store it in a cabinet. So that's not electronic. So, and that's like just loss of a lot of data, because once you put that in a folder or cabinet, nobody's going to take a look at it. So government, especially the United States government, they made a policy that encouraged the doctors to save, hospitals or doctors to save their activity in an electronic manner, so which is called electronic health records. And starting from early 2000, like a lot of hospitals start to adopt this system, this like EHR solution. And by year 2015, about 87% of the hospitals, like this is not just big hospital, but like local hospitals, or like even like single physician office, like in Korean term that would be 개원의, like like even single physician offices, they adopted electronic health record system. So this is year 2015. So I guess now by year 2021, more than, I would say, 93%, 94% of the at least in the United States, more than 93, 94% of the system hospitals are storing their data electronically. So that means that's just a lot of data. It's just like, humongous, gigantic amount of data just accumulating every single year. So that's just like truly a big data. So in that situation, we're in that situation. And as I said, electronic health records are stored in a relational database. So it has a very like complex structure. And it's just, this is just a graphical structure of EHR. Like usually there's the patient ID at the top, and then the patient makes the visit to the hospital, or like they go WEDE or IBON. So they go, there's an encounter, and then within an encounter, there's a lot of structured data, like what kind of diagnosis was given to the patient. And due to cough and fever, a doctor ordered a Tylenol, and the instruction was take it 3 times a day. Or maybe due to chest pain and abdominal pain, doctor ordered the EKG, and then the outcome was like some numbers. So like a lot of like structured data all come together. And yeah, so EHR is inherently a multimodal data. So EHR consists of structured codes. As I said, codes are like diagnosis codes, or like drug codes, or procedure codes. Like Tylenol is a drug code. Cough or fever is a diagnosis code. IV fluid is a procedure code. X-ray is also a procedure code. So it consists of structured codes. And of course, it also contains lab measures like your blood pressure, or your height or weight, or respiratory rate, or your body temperature, that kind of stuff. And spectrograms, like if you take EKG or EEG, like 심전도 or 뇌파, then that becomes a time series. And you can Fourier transform it into a spectrogram. Images is a big part of an EHR. So like, CT scans, MRI scans, X-ray images, they are part of EHR dataset. Free text, this is actually one of the most important modality in EHR, because doctors write detailed information in their notes. So doctors have their notes. So usually this is actually where like all the good information lies within. And like codes are very abstract and very like non-granular information. So actually doctors always say that you should always look at the free text when you do machine learning stuff, because people usually resort to these two, like structured codes and lab measures, but the fine-grained information is in the free text. So NLP techniques are really important in healthcare, actually. There are also other stuff like demographics, is whether you're married or not, with what's your gender, what's your date of birth, or what's your ethnicity. In the United States, it's a multiracial country, so ethnicity is also one part of the demographics. Billing information, with what kind of insurance you have, and genetic information, like what your DNA, your genes, or your that kind of stuff. So EHR is a multimodal data set, so it consists of a lot of different modalities, and that's actually one of the main challenges of handling EHR with AI technology, because usually machine learning is focused on a single modality. Like computer vision is usually just computer vision. NLP is just NLP. These days, it's all coming together a bit. So like there's like vision language models, or vision language learning, like multimodal learning is becoming a bit of a thing. But classically, it's just like, people who deal with images, they only deal with images. People who deal with text, they only deal with text. But in EHR, there are all sorts of different modalities. So if you really want to understand a patient, or the hospital activity, or the doctor's thinking, you need to look at everything. So that's one of the challenges. Right, so we've established what EHR is. I'm gonna just skip through the deep learning part, because I hope that everybody is already familiar with what deep learning is. So there's AI, and there's, as a subcategory, there's machine learning, and then subcategory is deep learning. So the deep learning, the reason that it is such a standard practice these days, like there's still like a lot of machine learning approaches out there, but everybody's using deep learning these days. And the reason is because of this performance. So this was pre-deep learning era ImageNet challenge era performance. So the error rate's 26%, means accuracy was 74%. And by 2016, again, Google Net, I guess this is InceptionNet. InceptionNet V4 was outperforming human accuracy by 2%. So this is 97% accuracy. This is 95% accuracy. So again, already the InceptionNet was outperforming human at least in image recognition part. So there's the state-of-the-art performance, which is what made deep learning popular. Then the next thing is, I think this is equally as important, less feature engineering. So before deep learning, what people used to do is, if you want to do like image recognition or image classification, for example, if you wanted to build a dog classifier, then you actually needed to inject your domain knowledge of dogs to the computers. So as a engineer or researcher, you needed to think about what differentiates dogs from other objects, other images, which would be like, it has eyes, or it has colors, or it has like specific colors, it has like specific like fur-like texture, it has like ears or tongues, and then you would actually need to write a program to capture these features and then train a support vector machine or something like that. So that would take a lot of time. Like every single time you wanted to build a specific classifier, like dog classifier, cat classifier, baby classifier, whatever, then you needed to actually come up with the features. But these days, it's just you dump the images in the raw pixel information, and then you let the machine figure it out. So these days machines, especially neural nets, they do both feature extraction and classification at the same time. So it's like I would say a democratization of machine learning. So like before, if you wanted to do image classification, then you needed to be like a master, like guru of images. You needed to know all the specific details and techniques and like hidden hidden sauces, like secret sauces for building an image classifier. And on the other end, if you were like an NLP expert, then you needed to know all the linguistic knowledge to build a really good NLP machine. But these days, you don't need that. You just dump your data into neural nets and then let it figure out. So the barrier for entering the AI research is really low now. Anybody who can write PyTorch code and understands basic machine learning knowledge, like training, overfitting, underfitting, or n-fold cross-validation, anybody who understands that and can use PyTorch, they can build a machine learning. They can build like state-of-the-art translation model, for example. So it's like a new era. So yeah, and the reason that the deep learning was actually this whole thing, like democratization of deep learning, was possible is due to, one, large data. So we live in a web-based world, so it's really easy to collect huge amount of data. And two is the machine, the hardware resources. So before, like in the early 2000s, it was already a web era. So we could, if we wanted to, we could collect a lot of data. I mean, we could collect a lot of data, but the hardware power was not there yet. So that's why by the year 2012 and 2013, deep learning started to gain popularity, because that's when people realized that they could use GPU to train neural nets. And these days, there's like whole variety of like resources, like TPUs and GPUs, and especially like Google uses TPUs to train like really gigantic models. And recently GPT-3, I think GPT-3 was trained on at least 1,000 or 2,000 GPUs. So yeah, we live in a new world. So due to the data and the hardware, this phenomenal, impressive performance was achieved. So in that respect, since we already have the hardware, and now we have the data, because of the adoption rate of EHR, as I said, the volume of data is just increasing day by day. So it's just it's now is like the right time to combine the two, the hardware and the humongous, gigantic amount of sheer volume of EHR. If we combine them together, then we could really make a lot of difference. Like these are just a lot of examples that I borrow from like a survey paper. But basically what they are saying is, with the combination of the two, you can save costs and save lives without much feature engineering, because thanks to deep learning. So I forgot to say, but like due to the less feature engineering, thanks to deep learning technologies, you as a AI researcher with minimal medical knowledge, you can still build a diagnosis classifier or disease prediction models, or or you can actually recommend like new chemical structure for like COVID-19 for drug discovery. Like you can all do that without much domain knowledge, thanks to the power of deep learning. So you can achieve save costs and save lives without much feature engineering. And as I said, saving cost is as important as save lives. As I said, you don't want to spend too much money in saving one patient life. That wouldn't be efficient. So you need to capture both at the same time in order to really make impact. And if you're interested in business, in order to run business, you need to think about both at the same time. All right, so this is I guess this is this is again. So we talked about healthcare for AI, and then we talked about EHR and the deep learning a bit. And I think that's all there is to talk about on laying the premise. So the structure of the structure of the course is, as you're familiar with Tuesday, Thursday, 10:30 a.m. to 12 p.m. I'll stress this again in the last slide, but please join Classum. Classum is a web-based course assisting platform, I would say. It's like, I think it was developed by Kai students. So please join Classum. I will make all the announcements and upload all the materials and all the YouTube links and all that on Classum. So please join Classum via this invitation code. So hopefully I'll post this information on KLMS, this Classum invitation code, so that nobody misses it. But please join Classum. And then grading scheme is so grading scheme is there are two options. One is project 1 to 3. So there will be projects, or it's more like an assignment. So project 1 to 3. So 3 assignments and 33% each. So you can choose to do all 3 assignments, or there's an alternative. So I'll describe it below. And there's no attendance score. So if you can come and go if you want to. If you want to learn, you can come. Or if you don't have time, you can just resort to the YouTube links, YouTube videos that I'm gonna upload every day. So that's up to you. Weekly schedule. So there was a bit of a change. So this is the updated version from the CAIS version. So today is the intro. Then we're going to talk about electronic health records a little bit next on Thursday. Then for maybe a couple of weeks, we're going to talk about predictive modeling. So how to pre-process electronic health records and then build a prediction model, like could be readmission prediction, or it could be mortality prediction, whatever. If you want to predict something based on EHR, there's a series of things that you need to go through. So we're gonna learn to do that for the first few weeks. And then the project 1 will be released. And then week 5, this will be like more of a Q&A session if you want to, or review session. When you do project 1, you might have some questions, so I'm going to be there to answer the question. Then week 6, and from week 6 to week 10, we're going to learn a bit more in-depth, more advanced techniques for predictive models. So concept embedding, interpretability, domain knowledge and graphs, medical text. And then after that, project 2 will be released, the same thing. Then the rest, 4 to 5 weeks, will be a bit more recent stuff. So except for medical image is the continuation of another modality. So medical text, medical image, and then week 12 will be multimodality. So as I said, EHR is a multimodal data set. So we're going to talk about multimodal learning a little bit, and then synthetic data. So using generative models, we can synthesize fake data, which is like one of the big topics in EHR or healthcare in general. Then number 14, we're going to talk about federated learning, which is one of the ways to deal with or overcome the privacy issues in healthcare. So that, and then project 3 will be released. And after that, it's going to be the final week. All right. And so project 1 to 3. So what is project 1 to 3? So project 1 to 3 is project 1 will be ICU mortality prediction. So you're going to use the ICU dataset. ICU is a 중환자실. So you're going to use 중환자 dataset to build a mortality predictor. Mortality meaning like death. So whether a patient will die in the hospital or not. So you're going to build that prediction model, and it'll be using structured EHR codes. So that's project 1. Project 2 is automatic billing coding. So using unstructured clinical text. So we're going to use doctor's notes to automatically predict what kind of diagnosis this patient will receive. So that's the second project. So this is another modality. Project 3 will be automatic diagnosis using chest X-ray images. So we're gonna use the chest X-ray images and then build a classifier, most likely using ConvNets or resonance. And so using an image classifier, we're gonna build a automatic disease classifier, like what kind of disease this patient has based on the chest X-ray, like tuberculosis or pneumonia or whatever. So we're gonna hit all three modalities: the structured codes, text, and images. Or so you can choose to do this if you're interested in learning the basics. Like if you want to cover all the modalities and then get familiar with how to build predictive models using different modalities, you can choose to do these. Or if you are if you're already all familiar with all these techniques, and you're just ready to do some advanced research, you can actually do the alternative, which is project 1 is shared. So you still need to do project 1 just as sanity check. And then from project 2, you can actually choose your own research topic. So that's research project. So that's the alternative option. So research topic is anything that is healthcare related, but it must be consulted with the teaching team first. So you can't just do any research and then just just call it an alternative. You have to consult with me to narrow down on what kind of research topic you want to do, and the final outcome must be at least a workshop paper. So workshop level paper, meaning 4+ page like academic paper. So it needs to have like an intro, related work, methods, experiments, and conclusion. So it's going to be like a very a legitimate, appropriate academic paper. And the team size must be 4 or less. So 4 would be probably more than enough, because usually our workshop papers can be written by 1 or 2 people. So yeah, so 2 options. If you're new to healthcare, if you're new to machine learning for healthcare, I recommend that you follow this. Actually, this is more like to get you like familiar with the topics and also techniques and all that. So, but if you're all familiar with all these, like you're just expert in healthcare, then I suggest you can do this. So there will be a time that I'm going to announce when to come up with the research topic and when to consult with me. So we're going to do that as we go. So probably after we've graded project 1. Yeah. Yeah. Again, another criteria is that unless you really get a good score in project 1, I suggest you don't do this. Like only you get a great score in project 1, probably you are ready to do this. So that could be another criteria. All right, moving on. So there's a set of prerequisites. There's the 3 categories in computer science. Hopefully you're familiar with data structure. I forgot to write discrete mathematics, but data structure, discrete math, algorithm and design analysis, database. You don't need to be an expert in database, but you must have at least used SQL and know what the tables are and know what the primary keys and the foreign keys are, because we're going to deal with EHR, which is the database. Math-wise, everything that leads up to undergrad level machine learning, like something like Andrew Ng's machine learning course. If you are familiar with all the materials in Andrew Ng's machine learning, then probably you're ready to do this. So all the math involved would be like calculus, linear algebra, stats and probs, preliminary optimization, like stochastic gradient descent, like mini batch gradient descent, ADA grad or ADAM, that kind of stuff. So that would be another set of prerequisites. Third is programming. So you must be familiar with Python and PyTorch. So because all the projects will be given based on PyTorch. So if you've attended AI504, which is programming for AI, which was given last semester, which was lectured by myself actually. So if you've taken this, then there's no worry. But if you haven't taken this, then please make sure that you at least are really you have an easy time handling PyTorch. So just as a like a FYI for your information, things that I taught in AI504 last semester are these. So like hopefully you are, so in order to attend this class, AI612 machine learning for healthcare, and get something out of it, then you must be able to write codes in PyTorch and do these most of these. So like you must be familiar with NumPy, scikit-learn, basic machine learning, and then you must be able to write logistic regression, multilayer, or MLP with PyTorch, autoencoder, VA. I mean, you don't need to necessarily be able to write all these from scratch, from zero, but you need to at least be, you need to be familiar with what they are, and have like a concept of how to code them if you were to code them, like VAEs, GANs, CNNs, word to vec, and cell word encodings. Cell word encoding being like sentence piece or word piece or byte pair encodings. RNN, seek to seek models like encoder decoder architecture. Image, you don't need to you don't need to care about 11. 12, transformers. Hopefully you are familiar with transformers and self-attention operations. BERT, which is just a extension of transformers. If you're not familiar with 14 or 15, that's okay. GNNs and neural ODs are a bit more recent stuff. So if you don't know what they are, that's fine. But at least hopefully you are familiar with from 1 to 12 and be able to code them, or at least look at other people's code and modify them. That is like the prerequisite. All right, so yeah, this so the teaching team will be, of course, the lecturer will be myself, and there are 6 TAs, and Kyung-Hoon Ho is the head TA. So if you have any question, you can direct your questions towards myself or Kyung-Hoon Ho. And yeah, I'll upload this material on KLMS and Classroom at the same time, so you don't miss the information. And so yeah, again, so just a brief introduction. Who am I to touch machine learning for healthcare? Like, who are you to teach us machine learning for healthcare? So just as a justification, so I got my PhD in Georgia Tech 2018, so that's like 2.5 years ago now. So my thesis was actually interpretable deep learning for longitudinal EHR. So I've been studying EHR for like now 7 years now, I guess. And before that, I used to work at ETRI, which is 한국전자통신연구원. So in that time, I used to do NLP research, like classical pre-deep learning NLP research, like part of speech tagging, named entity recognitions, or dependency parsings, that kind of stuff. All the stuff that was like a thing before deep learning came along. So classical stuff, and I used to use like structured support vector machines, conditional random fields, Markov models, like all the goody goodies from the back in the days. And then after that, I did a lot during the PhD. I did a lot of internships, mostly in healthcare or DeepMind in Google. And then after that, after graduating the PhD, I used to work at Google Brain and Google Health for 1.5 years before I joined KAIST last year. So I've been in this business for quite a long time now. So my background is NLP. Then after that, I moved to healthcare related stuff. So, and my main research area is, of course, machine learning, healthcare, NLP, and these days a bit more multimodal because of the multimodal nature of EHR. So, if you're interested in this research area, and if you have questions, you can always ask questions via email or during the class time. Actually, that's also fine. All right. Okay, so on the last note, please join Classroom. Again, I can't stress this enough because not a lot of people, I mean, we also have Naver engineers who are participating this course, and they don't have KLMS access. So that's why we're using Classroom. So please, everybody, do join Classroom. And I'm gonna say this again on Thursday, because we might have newcomers like auditors or 추가 신청생s and whatnot. So. Okay, and all right, so I guess this is the end for today. Any questions? Is this end for? Yeah, this is the end. So before we end, any question? Okay, interesting. No question at all. That's fine. Okay, I guess that's it then. I'll see you guys this Thursday. And as I said, again, so I'm gonna upload this to KLMS, but please do join Classroom. And yeah, if you have any question, you can upload, if you can post them on Classroom as well, or you can just shoot me an email. So, okay, thank you everybody, and I'll see you guys this Thursday. Bye-bye.